Today's project is a proximity alarm. This can be used on your door or inside your bedroom, something like that, to alert you with sound or alert the intruder when they've gotten too close. Now, this one, I'll give a simple demonstration, but then I'll test it out in real life because it has very good real-life applications. So let's test this out. So, I have my hand, and it's getting closer and closer. And at the range of 50 centimeters, it will detect your hand or anything and start to beep. And I can press this button to turn it off and reset it. And I've moved my hand in front of it again, and I'll reset it again. Now let's go check out the real-world application. As you can see, I've positioned the alarm in an optimal position at the entrance to my room. Now you can see as I try to exit, or to emulate someone entering, I'll walk by, and there you go. And I can just reset it by doing this. The materials. Today's program will be split up into 4 parts. Let's start on part 1. So, in part 1, we'll set up some variables. So we're going to have a const integer called piezo, which represents the pin that the piezoelectric speaker is going to be on. I'll copy that, and we'll make another one. And this one will be the pin that the button will be on. And that'll be pin 2. And finally, we'll have the ping sensor, or ultrasonic sensor, and that will be on pin 7. Okay, now we have to set up a boolean to check if anything has been detected in the range of the ping sensor. And by default, this will be false. Now, in the setup function, it's optional to set up the serial monitor, but it's helpful for testing, so I'll do that. Okay, now the next part is pin mode. Let's set up the pins. Now, notice when we set up the pins, we won't be doing it for the ping sensor, because that will actually be switching. The reason why is because the ping sensor only uses only one pin for both measurement and input and output. So it doesn't really work to just set it up in the setup function. Now we're on to part 2. Part 2 is the main logic inside of the loop function. So we'll be using a function that we'll create in a few seconds, but first we'll measure the proximity. And this will be in centimeters, and we'll check if that's less than or equal to 50 centimeters away. You can also, of course, change that to inches as well. And then we'll set detected equal to true if it's in that range. And now, now we'll check. Now the next part is checking the reading from the button. So we'll do digital read and from the button, and we don't need to say equals true because we're already actually checking if this is equal to true. So if this just returns true as like 1 or 0, if it returns true, it'll already work. And we can just set detected equal to false because we want it to not be detecting anything. We want to reset it if the button is pressed. Finally, we'll check if something is detected. So if detected is true, then we'll use another function we'll create later called buzz. Now, we've finished all the basic logic, so let's go on to part 3. Okay, so in part 3, we'll start by creating some helper functions. So first, we'll have a function called buzz, and this one will be to make the sound with the piezo speaker. Now this is probably the most adjustable part of this whole program. So first we'll create a tone on the piezo pin, and it'll last for, it'll be on 2000 hertz, and then we can wait for 500 milliseconds. So it'll go on for 500 milliseconds, and then we'll turn off that tone on the piezo pin, and then we can wait 250 milliseconds. Okay. Now, that should be that whole function done. Now, we can make another function called microseconds to inches. Now, we won't be using inches, but it's just in case you want to use inches in your own. So it'll take in microseconds, and because that's what the ultrasonic sensor returns, is time. And then we can use the formula microseconds divided by 74 divided by 2. And I'll just copy this because of the long name. And we can say microseconds to centimeters, and we'll take in a microsecond, of course, and we'll divide that by 29 and divide by 2. Okay. Now we're on to part 4, where we're going to be making the ultrasonic or ping sensors measurement. Okay, so this will return a long int, and we'll call this measure proximity with no parameters. Okay, so now we'll make 3 variables. One will be duration, the next will be inches, and the final one is centimeters, which we'll be using duration in inches mainly. Now, we'll first set pin mode to, of the ping sensor, and we'll set this to output, because we're going to be sending out a pulse. Then we can do digital write, and we will digital write to the ping pin, and we'll do low, because we're just going to make a quick reset. And of course we're going to use a new function, delay microseconds, because it'll be that fast, and this will only last for 2 microseconds. Then what we can do is another digital write, and we'll set the ping pin to high, so we'll send out a little pulse, and then we'll do that for 5 microseconds, and finally we'll set this back to low, because we want to end the pulse here. Okay, so that's the basic sending out the pulse. Now we'll set the pin mode of the ping pin back to input. That way we can measure from it, as that's what we will be doing. And we'll set the duration of it, that duration variable, to pulse in. Oops. And that's a way of measuring the length of that pulse that we sent out. And that's how we can measure it. And finally we'll set the centimeter variable equal to, I'll just copy this name from up here, microseconds to centimeters. And we'll pass in duration as the microseconds it's looking for. And then I'll set inches equal to microseconds to inches. And we can do duration there too. And we're on the last statement. This is where you can decide whether or not you want to use inches or centimeters. Now I'm going to use centimeters, so I'm going to return the centimeters. And that's the entire program. So